So in last lecture we discussed about the complete orthogonal transformation as well as incomplete orthogonal transformation, complete random orthogonal transformation. Okay, so these are the things we have discussed in the last lectures. So in orthogonal transformation we say that if C is a some orthogonal matrix and if X follows the multivariate normal, or you can say that x1, x2, xn are IID or normally independently distributed with mean 0 and variance 1, then if C is a some orthogonal matrix of order n cross n, and if you write y is equal to Cx is a transformation, okay, it's a linear transformation such that PC transpose is equal to identity, then we know the property that y1, y2, yn are also IID normal 0, 1. Second, we know that y transpose y is equal to x transpose x. That means x is a vector having the element an element. Okay, that means ki summation y xi square is equal to summation yi square. So, and if we say that the elements of C matrix C11, C1n, Cn1, Cnn, okay, the elements of the C matrix are orthogonal, then y1, y2, yn are normal, conditioning that C is a fix. That means we are trying to find out the distribution of y1, y2, yn, conditioning the C, then it is said to be a conditional orthogonal transformation. Both the results are remain the same. And if C1, C2, Cn are real values, it is not the random, then it is said to be a y1, y2, yn IID normals, unconditional normals, and this remain the same. And if the C is a rectangular matrix M cross N, okay, and if you are trying to find out the transformation y is equal to Cx, where C is M cross M, such that CC transpose whose order is M cross M, and it is the identity of order M. That means though x1, x2, xn are IID normal 0, 1, then if C is a rectangular orthogonal matrix, then the property is y1, y2, ym, because we are transforming how many variables? We are transforming the m variables. So they are IID normal 0, 1. And here we cannot write y transpose y is equal to x transpose x. That means this condition is not true. They are incomplete orthogonal transformation. Then how many variables are not transformed? So they are nothing but the n minus n. So we call them as a z transpose z is equal to x transpose x. There are the order of it n cross n. So that is, it is a summation xi square. Here there are n x having a n cross 1 and y having a m cross 1 minus y transpose y. Okay, that means summation I running from 1 to n xi square minus summation I running from 1 to m yi square. Okay, so they are the central chi-square with n minus degree of freedom, and they are independent. Further, Z transpose Z is independent with the y1, y2, ym. So this is nothing but the, here we said instead of C, we say it is a C1. So that C1 transpose is nothing but I crossing. So this is an incomplete orthogonal transformation. So that we have seen in the last lecture. Now let us understand with one example. If x1, x2, xn are independently distributed normal 0, 1 variables, and if x bar equal to summation I running from 1 to n xi upon n. So it is nothing but simple mean, and s square is equal to 1 upon n summation xi minus x bar whole square I running from 1 to n. It is a simple variance. Then find the distribution of v1, that is x1 minus x bar upon s. So if I am interested to find out the distribution of x1 minus x bar upon s. So we use the properties of transform variables. Consider an incomplete random orthogonal transformation. So we will not consider all the transformation. We will consider only two, that is y1. That means first variable is nothing but root n x bar, and y2 is nothing but root n upon n minus 1 x1 minus x bar. So I will consider this transformation. I will not focus on the y3 up to ym, because in complete orthogonal transformation we have a y1, y2, ym. So we are just transforming the m variables. So because to solve this example, this two transformation is sufficient to variable, so we will not go beyond of that. Then s square is nothing but, what is that? It is a 1 upon n summation xi minus x bar whole square I running from 1 to n. This can be written as 1 upon n summation xi square. Sorry, this is a not incomplete, this is a complete transformation. Okay. Minus n x bar square. So we can write this. But what is, when it is a complete transformation, what we can write? Summation xi square equal to summation yi square. And what is given? Y1 equal to root nx bar. So nx bar square equal to, I can write it is a y1 square. Okay. Why? Because y1 equal to root nx bar and summation xi square equal to summation yi square, because y is orthogonal transformation of x. Okay. So we can write it as s square equal to 1 upon n. It is a summation I running from 2 to n y I square, because y1 square is subtracted. So we wish to find distribution of
सर वॉल्यूम थोड़ा बढ़ाएंगे. हेलो.
v. So v is equal to x. What is that we wish to find out? V equal to x1 minus x bar upon s. Okay, so we wish to find out the distribution of x1 minus x bar upon s. Now, what is the y1? Y1 is nothing but
root and x bar.
root n x bar, and y2 equal to what we consider y2? It is
Root n
root,
upon n minus 1 into x1 minus x bar.
very good, root n upon n minus 1 into x1 minus x bar. So this we have considered. So here we have a x1 minus x bar, and s equal to what we can write in the form of y? It is a root 1 by n summation yi square. That is I equal to 2 to n. And x1 minus x bar. So that means here what you can write? y2 equal to, can you write? Root n minus 1 y2 is equal to root n x1 minus x bar. So can I write x1 minus x bar equal to root n minus 1 y2, and here it is a root 1 upon n summation I running from 2 to n yi square. So this is nothing but, can I write in this way, root n minus 1 upon n, it is y2 upon root summation yi square I equal to 2 to n. So that is, we have a v. But we know that x1, x2, xn are IID normal 0, 1, and because y1, y2, yn are the orthogonal transformation, so y1, y2, yn are also IID normal 0, 1. So here y2 is a normal 0, 1. Denominator summation, then you can say that summation yi square is nothing but it is a chi square with 1, because normal square is a chi square. So because we have y1, y2, yn are independently distributed, so I running from 1 to n, yi square is nothing but chi square distributed with n minus 1 by using the additivity property of chi square distribution. So according to that, it is a normal 0, 1 divided by the square root of chi square, and if you divide by the degree of freedom, then it is a what it will be? Then it should be a normal 0, 1, is it? Okay, here y2 we have taken, it is a, so it is y2 equal to root n minus 1, okay, root n, where is root n? Here it is not root n, we have x1 minus x bar, so we have to write x1 minus x bar equal to this, so this is the small mistake I have made here, it is a root n, and this n will be cancel out, so this is a cancel out. But if I wish to keep, if I don't want to divide, cancel out, so I can just write it as a root n here. Okay, so v is now this. Is it? Let me cancel out this. This is cancel out. This is cancel out. Okay. If I'll cancel out it, what I will have? There is no need for this. This root n minus 1 is in the numerator. So it is, if you can write in a denominators of denominators, then this root n minus 1 will be in the top. Okay. Now it is fine. So now v is equal to this. Now, if numerator is normal 0, 1, denominator is a square root of chi square divided by the degree of freedom. How many variables are there here? N minus 1, because it is start from 2 to n. Then according to the, it should be a t with n minus 1 degree of freedom. But when it becomes the t, when the numerators and denominators are independently distributed. But you can say that here the y2 is in the top and y2 is also in the summation is present. So we cannot say that y2 upon summation square root of y square upon n minus 1 are independently distributed. Okay, and that is how, if you remember, we have obtained the density of earlier. If you remember, x1, x2, xn are IID normal 0, 1. Okay, then we obtain the distribution of y. It is 1 upon summation x1 I running from 1 to n xi square upon n. And what was the distribution? The distribution of y was, anybody remember? Distribution of y was a, based on the t. We have just transformed the variable techniques and we have used, it was something like that. We have y square by n raised to n minus 3 by 2 divided by root n beta 1 by 2 n minus 1 upon 2, and the range of y is root n less than y less than root n. So this we have already obtained in the previous examples. So you can see that here it is a x1 and it is a complete summation xi square, because x1 is in the numerator as well as denominator. So therefore, by using the transformation of technique, we obtain the density of y this. It is not purely a t. Okay. So you can just compare this form with this. Here we have a x1 upon summation xi square upon n. Here we have a y2 upon summation y square upon n minus 1. So here we have a n minus 1 observation in denominators. So that is how it is divided by n minus 1. Here it is divided by the n observation. So that is how it is divided by the n. So wherever the n is present, we can just substitute n equal to n minus 1. Then we have the density of v is, by using this, substitute n equal to n minus 1, we get PDF of v, that is fv of v is nothing but 1 minus v square upon, instead of n it is n minus 1, and here it is a n minus 3, so n equal to n minus 1, so this is a n minus 4 by 2. Instead of square root n, it is a square root of n minus 1, and beta half of n minus 2 by 2, and the range of v is remain the same. This is the answer of B. So here instead, what you have to do while solving this example, you have to come with this, and then again you have to amend or augmented the previous examples methods, how we have solved this with y equal to x1 upon square root of xi square upon n, and then we obtain the distribution of y, and then we substitute it, we get the distribution of u. Okay, so this is the way we have to obtain. Any questions, anyone? course, here the range is not the n, but it is a, we have substitute n by n minus 1, so it is a root n minus 1. So these are the transformation of variable technique is over here. Again, we will use whenever we require the concept of transformation. Now we will obtain the non-central chi-square distributions. Okay, so before we know that this, so sampling from normal distribution. So we know that sampling distributions, what are the sampling distributions from normal? They are the chi-square, T and F. So they are said to be a central chi-square. And here in MSc, we will obtain the non-central chi-square. So I'll just give you the brief idea about the central chi-square distribution, which we have studied at the BSc level. Let x1, x2, xn be independently distributed as normal with mean mu I, variance sigma I square. I running from 1 to n. Okay, so I have not said here IID. IID means it has the common mean and common variance, but here each and every having the normal distributions, but they are independent with the different mean and different variance. Then, if we find out the distribution of standard normal variate, summation I running from 1 to n, xi minus mu I upon sigma I whole square is said to have chi-square distribution. How many such observation? Summation of n observation. Therefore, degree of freedom is with degree of freedom n. And is written as in notation y is distributed as chi-square with n degree of freedom. The PDF of y is, it is f of y is nothing but 1 upon 2 raised to n by 2 gamma n by 2 y raised to n by 2 minus 1 e raised to minus y by 2, and y is lies between 0 to infinity. We know that we have already seen that MGF. What is MGF? MGF is nothing but moment
Generating function.
generate function. So moment generating function of chi-square distribution is nothing but, it is denoted as mxt, and it is nothing but, we call them as e raised to tx, and in chi-square distribution it is a 1 minus 2t raised to minus n by 2. Okay, so when degree of freedom is n, here it is a minus n by 2, and it is in bracket 1 minus 2t raised to minus n by 2. And if you take the derivative of t, derivative of mxt with respect to t and equated to t equal to 0, we get the moments. So first derivative we get first moment, second derivative we get the second row moment, and by using the formula of the row moments we can obtain the mean. So that we obtained. What is the mean? If it is a chi-square with n degree of freedom, then mean of y is n, and variance of y is a 2n. So this we have seen in the BSc levels. Okay. So that is called central chi-square distribution. Now we wish to obtain the non-central chi-square distribution. Here what happened? We have given that xi is normal with mean mu I sigma I square. Now we wish to find out, instead of the xi minus mu I, okay, upon sigma I whole square, I wish to find out xi upon sigma I whole square, I running from 1 to n. Then it has not the central, right? Why? Because the mean mu is present. Okay, then it is a non-central chi-square with n degree of freedom, and non-centrality parameter is lambda, where lambda is nothing but summation mu I square upon sigma I square. So that we will prove. So non-central chi-square distribution, let x be distributed as normal mu sigma square. So that means x is a normal mu sigma square. Then y is equal to x square upon sigma square is said to have non-central chi-square distribution with non-centrality parameters parameter. It is lambda is equal to mu square upon sigma square. That means we are just substituting the expectation of x is nothing but mu. So here it is a x square. So we are just substituting the mean of x square. That is mu square upon sigma square with okay non-centrality parameter lambda equal to mu square, and how many observation? X is only a single variable, then the square of the normal is chi-square, so it is a degree of freedom 1. And in notation it is written as y is distributed as chi-square with 1 non-centrality parameters lambda. So now we wish to obtain the distribution of y. Here it is given that x is the normal sigma square. So I am interested to obtain the distribution of y, and I will show you that distribution of y is nothing but non-central chi-square with 1 degree of freedom, and non-centrality parameter is a lambda. We know that distribution function 2. We know that distribution function of y is f of y is nothing but probability that y less than equal to y. So what is y? Y is nothing but x square upon sigma square is less than equal to y. So it is nothing but probability that x square is less than equal to y sigma square. If you take the square root both the side, what will you get? It's a absolute value of x is less than equal to root y sigma. And if you just write this particular absolute, then it is nothing but the root y sigma less than or equal to x less than equal to root y sigma. And it is nothing but probability of x less than equal to root y sigma minus probability of that x is less than equal to minus root y sigma. Because we know that if the probability of a less than equal to x less than equal to b, we can write it as the probability of x less than equal to b minus probability of x less than equal to a. And this is nothing but the distribution function of x root y sigma minus distribution function of x minus root y sigma. Okay. So this is nothing but the distribution function of y. So density, how will you obtain the density? The density function is obtained by just taking the derivative of f with respect to y. The density function of y is d by dy with it is a derivative of fy with respect to y. It is a d by is fx root y sigma minus fx minus root y sigma. Okay, so this is nothing but fy of y small, it is a density. And what is the derivative of fx root y? So it is a small fx root y sigma. And what is the derivative of root y sigma? Sigma is a constant and root y is a 2 root y, 1 upon 2 root y. So it is a 2 root y. Similarly here it is a minus fx minus root y sigma. And what is the derivative of minus root y sigma? It is a minus sigma upon 2 root y. So this is minus minus plus, and if we keep the sigma upon root y outside to root y, it is nothing but fx of root y sigma plus fx of root y minus root y sigma. But we know that what is the fx? It is a star. We know that x is distributed as normal with mu sigma square. So what is the density of fx? Fx of x is nothing but 1 upon root 2 pi sigma e raised to minus half sigma square y minus mu whole square. And x is lies between minus infinity to infinity, and mu is lies between minus infinity to infinity, sigma square greater than 0. Okay, so substitute 2 star into 1 star. That means wherever you have x, just substitute x by root y sigma. Okay, using 2 star in star, we get what we get? F of y is equal to sigma upon 2 root y, and here we get 1 upon root 2 pi sigma e raised to minus half, where over x I have to write root y sigma minus mu whole square plus 1 upon root 2 pi sigma e raised to minus half, wherever x I have to substitute minus root y sigma minus mu whole square. Here it is sigma square. Okay, so I'll just take this outside, root 2 pi sigma. So sigma will be cancelled out. So what I will get? 2 root 2 y pi. Okay, because root y is there, root 2 pi inside, then sigma will be cancelled out. Is it? Then what will you get? Here it is a e raised to minus half root y sigma. I can write it as a y sigma square minus 2 root y mu sigma, okay, plus mu square. and here it is e raised to minus half square root of this minus minus whole square, that is it is a y sigma square, and this is minus 2 times, so this is minus, so it is instead of d it become the plus, so 2 times root y mu sigma plus mu square. Okay, so we just take this common, e raised to minus 1 by mu sigma square and mu square, this is the common from both the sides. Can we take or not? Here e raised to minus y sigma square plus mu square, and here it is also e raised to minus y, sorry, here the sigma square is there. Okay, so this is, here it is also a common, so I can write in this way, minus 1 upon 2 sigma square y sigma square plus mu square, and in bracket I can write e raised to, if I'm taking this inside, e raised to minus 2 sigma square here, so this 2 to cancel out and sigma is cancel out, so it is e raised to root y mu upon sigma plus, this is e raised to minus 1 by 2 sigma square is multiplied with this. Okay, so this 2 will be cancelled out, sigma square with this one sigma is cancelled, and this minus sign it, so this is minus root y mu upon sigma. So this is what we have. We call them as a 3 star. But we know that e raised to x plus e raised to minus x by 2 is nothing but it is a cos hyperbolic x. Okay, it is a cos hyperbolic x. Okay, that we will not right now use, later on we will use. Okay, so what we can write for this, we know that e raised to x, expansion of e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus up to, okay, it is infinite series, and here e raised to minus x equal to, it is a 1, then it is a minus x plus minus x whole square upon 2 factorial plus minus x cube upon 3 factorial, likewise. So you can see that if you take minus outside, if you take the sum of these two, so what happens, this minus x plus x will be cancelled out, so here it is a 2 plus, here this is x square by 2 factorial, minus x square is also x square, so it is a 2 times x square by 2 factorial. This minus x cube and plus x cube by 3 factorial cancel out, next term is a 2 raised to x4 by 4 factorial, so likewise. So it is nothing but, if you just take the twice is common, it is 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial up to. So can I write in this way? It is a twice of summation, let us say r equal to 0 to infinity x raised to r upon r 2r factorial, r equal to 1, x raised to 0 is 1, 1 upon 0 factorial is 1, so 1 by 1 is 1, r equal to 1, then x raised to 2 divided by 2 factorial, r equal to 2, then it is x raised to 4 by 4 factorial, so I can write this. So what I have given it is a root y mu upon sigma, so I can write it is a twice of summation root y mu sigma whole square divided by 2r factorial. Then fy of y is nothing but what you have, it was a 1 upon 2 root 2 pi y into e raised to minus 1 by 2 sigma square it is a y sigma square by mu square, and we can write it as a twice of, because twice of into summation r equal to 0 to infinity. What is x? X is in our case, it is a root y mu by sigma raised to 2r upon 2r factorial. So this 2 will be cancelled out with this. We can write it as a 1 upon root 2 pi. Y we will take and root y is there. It is a e raised to minus this, particularly sigma square is cancelled out. Okay, with that, so it is nothing but e raised to minus y by 2 minus, it is a mu square by 2 sigma square into summation r equal to 0 to infinity. It is nothing but sigma raised to 2 upon r is outside, so I can write it as sigma raised, okay, not take outside. It is nothing but root y mu raised to r 2r divided by sigma raised to 2r into 2r factorial. Okay, can we write this? Okay, this sigma is cancelled out, no? So no. It is here, okay, root y sigma is a twice. Okay. Now we substitute in the same. Now substitute one sigma is cancelled, na? Why this sigma I am writing? This is already cancelled out, na? There is no sigma here. Okay. Now substitute lambda equal to mu by sigma. So wherever you get, it is called the non-centrality parameter. So we get Fy lambda is 1 upon root 2 pi into root y e raised to minus y by 2 into e raised to, or you can say it is a minus lambda square by 2. Is it? It is a minus lambda square by 2. No. We will write lambda equal to mu square by sigma. So it is a lambda by 2. Okay. Because mu square upon sigma square is this. And what here we can write? R equal to 0 to infinity. So here it is a mu square upon sigma square. So it is nothing but the lambda. So it is nothing but root y into lambda raised to 2r upon 2r factorial. Not the lambda raised to 2r, lambda raised to r. So we can write it as y raised to r because here we write mu square upon sigma square. It is a lambda, so this is lambda raised to r, and root y square is y. Sorry. So it is nothing but y into lambda raised to r upon 2r factorial. Okay. Let us say it is a 4 star. Now use the duplicate gamma formula. Using duplicate gamma formula. What is the duplicate gamma formula? it is gamma r plus 1. Whenever you get this is gamma r plus 1 into gamma r plus 1 by 2 is always written as a root pi into gamma 2r plus 1 upon 2 raised to 2r. Okay, so what is given? Here we have given the 2r factorial. So what is the 2r factorial? Gamma 2r plus 1 is nothing but it is a 2r factorial, because we know that gamma n plus 1 is nothing but n factorial. Okay, so here 2r plus 1 is equal to 2r factorial. So just substitute the 2r factorial is nothing but gamma 2r plus 1. So what happened? Gamma 2r plus 1 is nothing but this 2 raised to r is multiply this and the root pi. Okay, so we have for this, by using this gamma duplicate formula, gamma r plus 1 gamma r plus 1 by 2 into 2 raised to 2r upon root pi. Okay, this we have. So just substitute 2r factorial equal to this quantity into the equation 4. What is equation 4? It is a root 2 pi y. It is a 1 upon root 2 pi root y as it is. Later on we will write a y. E raised to minus y by 2 into e raised to minus lambda by 2. Okay, because we can write. And it is a summation r equal to 0 to infinity y lambda raised to r, and upon 2r plus 1, 2r factorial is equal to, we can write this root pi will be in the upper side. I will write here it is a root pi. Okay, and what I can write, this is gamma r plus 1 gamma r plus 1 by 2 into 2 raised to 2r. So if we write this root pi will be cancelled out. If we write the terms of lambda together and y together, what we can get? R equal to 0 to infinity. This is y raised to half. It is in the bottom, so it is a y raised to minus half e raised to minus y by 2. Okay, upon what we can write, upon root 2 into 2 raised to 2r. Here it is a y raised to r upon gamma r plus 1 gamma r plus 1 by 2 into lambda raised to r. Okay, so it is not y by 2, it is a minus lambda by 2. So keep all lambda term together. We can write r equal to 0 to infinity e raised to minus lambda by 2, and here it is a 2 raised to r. Okay, so here we can write it as a lambda by 2 raised to r. So 1 2 raised to r is present over there. Okay, and here we can gamma r plus 1 is nothing but r factorial into what we can write, it is a y raised to 1 by 2 minus 1. Okay, 1 minus 1 by 2 it can be written as 1 by 2 minus 1 y. Yes, e raised to minus y by 2 is also there. Okay, so it is e raised to minus y by 2. I think I made mistake. Let me check. It is minus lambda by 2. Then what happened? Y raised to r is there, divided by what you will get. Here lambda is power r, 2 raised to r. So we have 1 2 raised to r. This is 1 by 2. So it is a 2 raised to r plus 1 by 2. And this is the gamma r plus 1 by 2. Okay. So we can write it as a r equal to 0 to infinity e raised to minus lambda by 2 raised to r upon r factorial into here y raised to r, so you can write it as a y raised to r plus 1 by 2 minus 1 e raised to minus y by 2. This is nothing but gamma r plus 1 by 2 into 2 raised to r plus 1 by 2. So this is nothing but the density of, if you write r plus 1 by 2 is equal to n, so that is nothing but y raised to n minus 1 into e raised to minus y by 2 divided by gamma n plus by 1 by 2, and it is nothing but, or you can also simplify further, it is r equal to 0 to infinity. What is the distribution of Poisson? It is e raised to minus lambda raised to x upon x factorial. So here instead of lambda we have lambda by 2 and x की जगह पे हमारे पास क्या है r factorial. So can I write it as a Poisson with r and parameters lambda by 2. Okay, this is the probability mass function of Poisson distribution with parameter lambda by 2 into y raised to this 2 multiply with this, so 2r plus 1 by 2 minus 1 e raised to minus y by 2. This is 2 raised to 2r plus 1 by 2 into gamma 2r plus 1 by 2. Okay, to the, so if you say 2r plus 1 by 2 is nothing but n by 2, then it has the form y raised to n by 2 minus e raised to minus y by 2, 2 raised to n by 2 into gamma n by 2. So this is nothing but the PDF of a central chi-square. Just substitute n equal to 2r plus 1. So it is y raised to 2r plus 1 by 2 minus 1 e raised to minus y by 2, 2 raised to 2r plus 1 by 2 into gamma 2r plus 1 by 2. So that is what we have. So it is nothing but the central chi-square. This is the probability of a Poisson distribution where r is your random variable with parameters lambda by 2, and this is a chi-square with 2r plus 1 degree of freedom. Okay, where, so this is nothing but the density of y. What is y? Y is equal to x square by sigma square, where PR lambda by 2 is the Poisson probability of R, that is random variable, with parameters lambda by 2, where lambda is equal to mu square by sigma square, and chi-square 2r plus 1 is the density of central chi-square with degree of freedom QR plus 1. Okay, this is a non-centrality parameter with the 2r plus 1. If you substitute, let us say lambda equal to 0, what happens? So when you substitute the lambda equal to 0, or you can say that when the non-centrality parameter is 0, okay, when non-centrality parameter is 0. When you say that non-centrality parameter is 0, it means mu square by sigma square equal to 0, which implies mu square equal to 0, which implies mu equal to 0. So when you substitute mean is 0, okay, the mean of y, that is 0, that is non-centrality parameter is 0, then non-central distribution is reduced to central chi-square distribution. Okay, so whenever you substitute lambda non-centrality parameter is 0, then it reduces to central. So it means that if x is normal with, let us say, mu sigma square, which implies y is equal to x square upon sigma square is non-central chi-square with 1 degree of freedom, and non-centrality parameter is lambda. But if mu equal to 0, which implies x is non-central with mean 0 sigma square, then y is equal to x square upon sigma square, which is a chi-square with 1 degree of freedom. So let me non-central distribution reduce to central distribution. Any questions, anyone? Yes, any questions? So there is another theorem. Let x is distributed as chi-square with m degree of freedom, and y is distributed as chi-square with 1 degree of freedom and non-centrality parameters lambda. Both x and y are independent. Then the sum of independent variable, let us z is equal to x plus y, is distributed as non-central chi-square with degree of freedom m plus 1 and non-centrality parameter lambda. Okay, so it means that what property here? If any one of the random variables has the non-central chi-square distribution, the addition of two independent random variable is chi-square, subtraction of two independent variable is there also a non-central chi-square, ratio of two ratio of the chi-square to non-central chi-square is also the non-central, but it is a non-central f. So if any one of them, numerator, denominator, addition, subtraction, any one of the variable has the non-central chi-square distribution, the transform random variable distribution is non-central, whether it may be t, it may be chi-square, it may be f, depends on the nature of transformation. But we know that if x and y are two independent chi-square, then the sum is nothing but it is also chi-square by sum of their degree of freedom. So here x having a chi-square with m and y is a chi-square with 1 and lambda, then x and y are independent, we will use the additive property. The additive property is the chi-square with m plus 1 degree of freedom, but here non-centrality is present, so now it is a non-central chi-square with m plus 1 degree of freedom. So proof. Proof you can give by using the two methods. One is based on the transformation variable technique, and another is based on polar transformation. So transformation variable technique, you know that at the homework, There you have to take, let us say, z is equal to x plus y and y is equal to y. Okay, and just find out the Jacobian and then substitute the value of z, integrate over the y, we get the density of z. Okay, so that it is in the homework, but I will show you by using the polar transformation. Since x and y are independent, their joint density is given by fxy xy is equal to fx of x into fy of y. So we know that this, since x is distributed as chi-square m, y is distributed as chi-square with 1 lambda, then fxy xy is equal to, what is the fx x, that is chi-square m, it is a 1 upon 2 raised to m by 2 gamma m by 2 y raised to m by 2 minus 1 e raised to minus y by 2 multiply by chi-square with 1 lambda. What is that? It is a summation r equal to 0 to infinity. So it is a Poisson with r random variable parameters lambda by 2 into e raised to minus y by 2 y raised to 2r plus 1 by 2 minus 1 upon 2 raised to 2r plus 1 by 2 gamma 2r plus 1 by 2. Okay, so just make this term together. That later on we can do, or by transformation of variable you just make the term together. Oh sorry, here it is a x, because x is nothing, so it is not dy, here it is a x. So just make a term together of x and y wherever you can have the x plus y. For example, e raised to minus x by 2 and e raised to minus y by 2, so it is e raised to minus x plus y by 2. So wherever you have a x plus y, just substitute z, and whenever you have x, substitute z minus y, and then integrate over y, you will get the density of x. But here we will use the polar transformation. Let us make a polar transformation from xy to z theta, where x equal to, what is x equal to? Z cos square theta and y equal to z sin square theta. So what is the Jacobian of xy to z theta? It is nothing but the derivative of x with respect to z and derivative of x with respect to theta, derivative of y with respect to z, and derivative of y with respect to what is that? When you take the derivative of x, partial derivative with respect to z, it is nothing but cos square theta. This is nothing but it is nothing but cos square derivative is 2 cos theta. Okay, and cos theta derivative is minus sin theta. So it is a 2 times minus z sin theta into cos theta. Similarly, what is the derivative of phi with respect to z? It is nothing but sin square theta. And derivative of phi with respect to theta is nothing but 2 times sin theta cos theta. Of course, z is there. Just multiply this. You will get 2z sin theta cos cube theta minus minus plus 2z sin theta, sorry, sin cube theta cos theta. So just take the common 2z sin theta cos theta. You will get cos square theta plus sin square theta. And cos square plus theta plus sin square theta is 1, so it is a 2z sin theta cos theta. So Jacobian is this. So just wherever the x, we will write this. So density of f z theta is nothing but, what is x? X is nothing but, let us say we write r equal to 0 to infinity position of lambda by 2 into, here you can see that e raised to minus x by 2 into e raised to minus y by 2, that is e raised to in bracket minus x plus y by 2. And what is x plus y? So x is equal to zx cos square theta and y equal to z sin square theta. So x plus y is nothing but z into cos square theta plus sin square theta, that is 1. So it is a z. So it is e raised to minus z by 2. What is x? X is nothing but z cos square theta, and it has the power n by 2 minus 1. Okay. What is the power of y raised to? So y raised to, here we have a 2 raised to r plus 1 by 2. And what is y? It is nothing but z sin square theta 2r plus 1 by 2 minus 1. And what is the Jacobian? Jacobian is a 2z sin theta cos theta. And divide by, what is the divide by? Here it was a 2 raised to m by 2, and here it is a 2 raised to r plus 1 by 2, so I can just add it, 2r plus 1 by 2 into gamma m by 2, and here it is a gamma 2r plus 1 by 2. Can we write? Yes or no? So what will you write here? R equal to 0 to infinity PR lambda by 2. Here it is a, what is, we write all the terms of z together, so it is a z raised to m by 2 minus 1 plus 2r plus 1 by 2 minus 1 and z power 1, that is plus 1 into e raised to minus z by 2. And what is the term of cos? Here I will write, let us say 2 raised to m plus 2r plus 1 by 2 And if I am multiplying this m plus 2r plus 1 by 2, this is additional term, so I have to divide it. So I can write here, it is in the top, m plus 2r plus 1 by 2, and this term I am writing here m by 2 and gamma 2r plus 1 2 as it is, gamma m by 2 gamma 2r plus 1 by 2. And now I am writing the term of theta together. It is a cos square theta raised to m by 2 minus 1. Okay, here the power is 2, so one power will be added here more, but okay, we will see that later. And so cos theta, if we write the power of cos square theta m by 2 minus 1, so here it is a cos theta, so square theta I can write it as a plus 1 by 2. Okay, so cos square theta power 1 by 2 is nothing but cos theta, and here sin square theta raised to power, what is that, 2r plus 1 by 2 minus 1 and plus 1 by 2 of this cos theta. Okay. Any missing part? Okay. Now last we will see about this 2, where it is 2. That is here 2 is multiply with this. So what is this form? R equal to 0 to infinity probability of R lambda by 2. Here you can say that it is m by 2. This minus 1 will cancel out this plus 1. So this are cancel out. So it is nothing but m plus 2r plus 1 by 2 minus 1 e raised to minus z by 2 divided by 2 raised to m plus 2r plus 1 by 2. Okay, into gamma m plus 2r plus 1 by 2. Okay, so this is nothing but the, okay, and into 1 upon, what we can write, it is a form of the beta m by 2 2r plus 1 by 2 into cos square theta. What is cos square theta? It is a m by 2 plus, so here we can write it as a m by 2 minus 1 by 2. That means it is a, you can say that m plus 1 by 2 minus 1 over m by 2. Okay, you can write m by 2 minus 1. Let us see. It is a m by 2 minus let us say here we can write it as a, as it is, we can, and it is a 2 times 2 is here we can take in, so it is a 1 by 2 plus 1 minus 1. Okay, and sin square theta is nothing but 2r plus 1 by 2 plus 1 by 2 minus 1. Okay, so you can see that both z and theta, this is the density of z and this is the density of theta, both are independent. So both z and theta are independent. Therefore, density of z is equal to x plus y is, what is that? It is f of z. Z is nothing but summation j r equal to 0 to infinity pr lambda by 2 into z raised to m plus 2r plus 1 by 2 minus 1 e raised to minus z by 2 upon 2 raised to m plus 2r plus 1 by 2 into gamma m plus 2r plus 1 by 2. And this is nothing but, if you write, it is a m plus 1 plus 2r by 2 e raised to minus z by 2, then it is nothing but, it is the density of chi square with m plus 1 degree of freedom and non-central parameters lambda. Hence the proof. So if x having the chi square m, y having the chi square 1 with lambda, then z is equal to x plus y having the chi square m plus 1 lambda, that is non-central chi square with m plus 1 degree of freedom and non-centrality parameters lambda, provided x and y are independent. Okay, any questions? Anyone?